So for this one, use the Riemann sum to approximate the area of the triangle region bounded by the graph of f of x equals 5x and the x-axis of 0 to 3. All right, and use the partition of 6 subintervals and choose C sub I to be the left endpoint. Again, left endpoint of the subinterval. So again, this is telling us that we're going to do the left Riemann sum. All right, and then compare this approximate area to the actual area of the region. So this graph, well, first of all, we need to find, what do we need to find first? Delta x. So how do I find delta x given this information? You tell me, what's n? How do you know? Partition of 6 subintervals. 6 subintervals. Right there, underline, 6 subintervals. So that's 1/2, right? So again, what does delta x represent? All right, you write it. That's the width of the rectangle, right? So we got to go from 0 to 3. So here we go. We go 1/2, 2 halves, 3 halves, 4 halves. Oh, I put fourths. Oh my gosh. You see what I did?
Thank you.
I'm tripping. All right, see you later. 1/2, 2 halves, 3 halves. How far do I go? 4 halves, 5 halves. How far do I go? 6 halves. Why do I go to 6 halves? That's 3, right? This is 2 halves is 1, 4 halves is 2, and this is 3. And we got to go from 0 to 3, right? So there's our rectangles right there. They're 1/2 apart. Oh, what's the y value right here? No. 5x. So 0 times 5 is 0. So this thing goes like that. So this rectangle will be like this. And you can graph it to see it. You know what I'm saying? But I know it's going to be like that. Now, again, we're doing the left Riemann sum. So do we need the midpoints? No. We don't need them because we're not doing the midpoints. All right. So now we need to find the approximate. How do we find the approximate again? Times what? F of 0 plus to what? F of 5, 6. Why not 6, 6? Yeah, that's the right endpoint. We don't need the right endpoint for this one. So you guys give that a second, give that a try, and then tell me what you get for the approximation. Let me fix it again, cause dude, I just be writing, man. 2 halves, 3 halves, 4 halves, 5 halves. There we go. I was saying it, I think, but writing something else. Tripping. All right, so 0 to what? 3. All right, and then we do 5x dx. All right, and go ahead and do that and tell me the exact value. Oh, I'm sorry, what was it? 22.5. You got a second on that? Yeah? All right, 22.5. Man, I know you did. No, so this is the right Riemann sum. All right, you're not using the left endpoint. So this time when you find the approximate, all right, what was delta x again? It's the same problem. So what's delta x again? Was it 1/2? So you do 1/2 times f of, I'm sorry, not f of x, but f of what? What do we start this time? F of 2 halves, right? And we're going to carry that to f of what? 6 halves or 3, right? 6 halves is 3. Because we're not using the left endpoint this time. So what's the approximation? And then when you're done with that, well, we need to find the exact. The exact's the same.
Yeah.
The exact's still going to be the integral. So we just need the approximation on this one. What's wrong? You have the hiccups. Oh, you need to be burped. That's what that means.
Why do we start from 2 halves?
Because we don't need the left endpoint. Oh, snap. Correct. Guys, you start from 1 half.
Yeah, I was like, wait, hold on.
We don't start at 2 halves. Sorry. The left endpoint was 0, right?
Mm-hmm.
So we start at 1 half. So 1 half to 3. 3 is 6 halves. So you remember that number line we had, right? Where it was 0, 1 half, 2 halves, right? We start here now. We don't include this one. Because it's the right Riemann sum. And we go all the way 3 halves, 4, 5, 6. 6 halves. And that's 3. 6 divided by 2 is 3. Because this is the right side. So for this one, y equals, what's the equation, 5x? 5x, so there's the graph. All right, table, we got 0, 0.5, 1.5, that's 3 halves. 1 half, 2 halves, thank you, 1. 2 halves is 1, right? Here, I'm just gonna do it. 2 halves, 3 halves, 4 halves, 5 halves. Wait, did I skip 4 halves? No, I did. And then 6 halves is 3. Right? Did I do it right? All right, cool. So now, if we do 1 half, oh, I don't even know why. Listen, let's just type it in. So we got 1 half times 2.5 plus 5 plus, yep. Ooh. Looks good. What? What'd you get? No way. You got 0.5 times 2.5 plus 5 plus 7.5 plus 10 plus 12.5 plus 15. No way. All right, let me look. Right.